In this lesson, we're going to be reviewing a number of concepts that you would have seen in Year 7. We'll start by reviewing some of the words we'll be needing, and so the first one is factors. Now, anytime I multiply two numbers together to get a value, then these two numbers are factors of whatever value I get. So 3 and 4 are both factors of 12. And so 2 and 6, because 2 times 6 is 12, and so is 1 and 12. Now we're only dealing with whole numbers here, and so all the factors of 12 are 1, 2, 3, 4, 6, and 12, because they're all the numbers that I can multiply together to get 12. Another way of thinking about it is, if I want to get the factors of a number, what numbers go into that value without remainder? Because you'll find that all of these numbers here, 1, 2, 3, 4, 6, and 12, they all go into 12. You can divide them into 12 without getting any remainder. The next one is multiples, and when I take any whole number and I multiply it by another whole number, I get a multiple. And so because 3 times 1 is 3, that means 3 is a multiple of 3. And then I could do 3 times 2, which is 6, which means 6 is also a multiple of 3. And then 3 times 3 is 9. Notice it's really just the times tables, isn't it? It's just going up by 3 each time. So these are all multiples of 9. 3, 6, 9, 12, 15, and you keep going from there. You can have as many multiples as you want of a number, because you can just keep timesing it by any other whole number you want to. Another one I could do is 3 million, because 3 times a million is 3 million. And so the question to be asked when you want to get multiples is, what numbers does the value go into? Because you'll find that 3 goes into 3, 6, 9, 12, 15, and so on. So what numbers does the value go into without remainder? The next one is to do with squaring, and that's when you've got the little number 2 up the top here. And so this is the same as 5 times 5, which is just the same as 25. So anytime you've got a number with the little 2 up the top, it just means multiply that number by itself. And finally, we have square rooting, and when you see that square root sign that looks like this, it means find a number that multiplies by itself to get whatever's inside the square root sign. And so in this case, it's going to be 6, because 6 times 6 is 36. So if I'm looking for the square root of 36, I say it's just equal to 6. And so square rooting is the opposite of squaring. Let's take a look at these concepts that we need to know. The first one is the lowest common multiple, and it's the lowest number that's a multiple of both values. So if I was looking for the lowest common multiple of 5 and 3, I would start by listing the multiples of 5, and of course they could go on forever, so I'm just going to restrain myself and just show the first 6. 5 or 6 is fine usually, and then I'll list the first however many multiples of 3. All I'm really after is the lowest one that's on both lists, and we can see there 15 appears on both lists, and there's no number that's lower than it that's on both lists, and so 15 is the lowest common multiple of 3 and 5. A similar idea to that is the highest common factor, and this is where we list factors of both numbers. So if I'm after the highest common factor of 10 and 15, then I list all the factors of 10 to start with. So remember, that's just what numbers go into 10. So 1, 2, 5, and 10 without remainder. And then what numbers go into 15? And I am looking, because this is the highest common factor, I'm looking for the highest number that is on both lists, which in this case is 5. Now, notice if you got it confused and you said the lowest common factor, that's always going to be 1, because 1 is a factor of every single number. And so it's lowest common multiple and highest common factor. The next concept is prime numbers, and prime numbers have exactly 2 factors, itself and 1. If it's got more than 2 factors, we call it a composite number. And so if we have a look at the number 20, we want to know if it's prime or a composite. We could start by listing all its factors, so all the numbers that go into 20 without remainder. And so 1, 2, 4, 5, 10, and 20. Since there are more than 2 of them, that means that it is a composite number. It's not prime. If we have a look instead at the number 11 and we list all its factors, only 1 and 11 go into 11 without remainder, and so that means that it is a prime number, because its only 2 factors are itself and 1. There's another number we should look at, and that is the number 1 itself. If we list all of the factors of 1, there's only 1. No, 1 is the only factor of 1. And since that does not have exactly two factors, we're not going to call it a prime number. And we're not going to call it a composite number either, because it doesn't have more than two factors. Now, there is a little bit of debate in the mathematics world. There always has, about whether or not 1 should be a prime number, but consensus generally is that it shouldn't be. The next one is the concept of these index numbers. And so we know that if you see 5 to the power of 2, that's just 5 times 5, which is 25. Now, I can change that number. I can make it whatever number I want up there. So 5 to the power of 3, that just means 5 times by itself 3 times. And so that's 125. And 5 to the power of 4, that's just 5 times by itself 4 times. So the idea is pretty simple, although working out the actual answer can get a bit more complicated without a calculator. But it's just whatever that number is, multiply this, it's called the base, multiply the base by itself this many times. And the next one is when we have our square root sign, or we should just call it our root sign, because it doesn't have to be a square root we're about to see. And so this is the one we're familiar with here, and we know that the answer to square root 36 is 6, because 6 times 6 is 36. But we can actually put a little number up here. And so if I put a little 3 up there, that means now I'm asking what times is by itself 3 times to get to 216. And it's 6, because 6 times 6 times 6 is 216. And I could put a little 4 up there. I can put whatever number I want to. So if I put a 4 up there, now I'm looking for something that multiplies by itself 4 times to get whatever number is in here, 1296. And in this case it's 6 again. I've chosen the numbers inside the root signs in this case to always have the answer of 6. And so 6 times 6 times 6 times 6 is 1296. So that's why the answer is 6. Now, these can be quite difficult to work out if you've got really large numbers. Fortunately, generally speaking, you'll be kept to pretty low numbers, and the best way to work them out is just by trial and error. And so if I'm trying to work out what times is by itself 3 times to get 216, well, I might start off with 2. Well, 2 times 2 times 2 is only 8, way too low, and I keep going up until I work out that it's 216. Okay, let's take a look at some examples now, and we'll be focusing particularly on our setting out of our working here. So we're going to start by finding the lowest common multiple of 4 and 6. And so we need to list the multiples of 4 and 6. We can just do it like this on 2 different lines there. And notice, of course, I haven't kept going forever. Really, all I'm looking for is the lowest number that's on each list. So just list a couple of multiples of it. Well, 4 or 5 is usually a good start, and then start listing on the bottom one, and as soon as you get to the same number, the first same, you can stop. So I didn't even technically have to write down the 18 here, because once I'd written down 6 and 12, I already knew 12 is now the lowest number on each list. So the lowest common multiple is 12. Make sure we state our answer clearly. The next example asks about the highest common factor of 16 and 20. And so we want to list the factors of 16 and 20. So starting with 16, I find it easiest to list factors just by finding 2 numbers that multiply to get 16. The first ones I always write down are 1 and the number itself. They're generally easiest. And then I start thinking, okay, well, another way to get it is 2 times. Does 2 times something get 16? And it does. 2 times 8 gets 16, so I write down them. Then I think 3 times something. No, can't think of anything for that. What about 4 times something? 4 times 4 gets 16. Remember, you only have to write down the 4 once. And so there's my factors of 16. And so now I can go on to 20, and using that same process, these are the numbers that I would get. And then all I have to do is look for the highest number on both. Now notice there's a 1 on both, there's a 2 on both, but they're not the highest. 4 is the highest. So always look carefully for the highest number that's on both, and then make sure you write down your final answer. The next example is to do with the prime numbers. We want to know if 15 is a prime or a composite number. Remember, all we need to do is know, does 15 have more than 2 factors? And so I'm just going to see, is there anything that I can multiply to get to 15 except for 1 and 15? And in this case there is. There's 3 times 5. So all I have to do is show that there's any numbers apart from 1 in itself that multiply to get to 15. And if that's the case, then I can just say it's a composite. It's not a prime. If I couldn't think of anything, I'd write down 1 times the number itself, and then I'd say it's a prime. So that's just an easy way of showing our working here. You don't need to list every single factor, because we only need to know if there's anything except 1 and itself. In the next one, we're going to be evaluating 5 cubed. That's the little index number up there. So we start by writing down the question, 5 cubed, and that is equal to 5 times 5 times 5. And then we work that out, which is 125. Now, notice that I've put it on the next line down. We don't want to put multiple equal signs on the same line. So we can do that, but then the answer goes on the next line down nice and neatly underneath it. In the next example, we're going to be using that little root sign here, and it's got a little 3 up the top, and so that means we're looking for a number that multiplies by itself 3 times to get 64. And so a little bit of trial and error here. We know it's not 1 times 1 times 1 because that's only 1. What about 2 times 2 times 2? If we work that out, it's 8, so that's not the answer. If we do 3 times 3 times 3, we work it all out, we get 27. That's not the answer either. 4 times 4 times 4 is 64. 4 times 4 is 16, and 4 16s are 64. And so that's the easiest way to do it, just a bit of trial and error. And so we get the cube root of 64 is equal to 4. And we don't want to leave it there. We just want to show why that works. So just underneath, in brackets, we're just going to say that's because 4 times 4 times 4 is equal to 64. Okay, let's try a few practice questions now. Remember to set out the working as it went through in the examples, and remember to pause the video until you're ready to see the answers. And there's the solutions there. Remember to check your working. You should have all of the working that we have got here. Okay, let's have a look through those and see how they're done. So the lowest common multiple of 9 and 6, I started by listing the multiples of 9 and the multiples of 6. Remember, they're the numbers that 9 goes into, and so just the times tables for 9, and the same with 6. And I didn't have to do too many before I saw that 18 was on both lists. If I hadn't found a number on both lists, I just would have listed a few more multiples in each one, but since I'd already found 18 there is on both lists, I wrote that down as my answer. That's the lowest common multiple, and I moved on. With the next one, we're looking for the highest common factor of 25 and 30, so I had to write down all the factors of 25 to start with, and I used that same method I talked about in the examples. I started by writing down 25, and then I thought, well, what else multiplies to get 25? And the only one I could think of was 5 times 5. And so I wrote down the 5. When it came to 30, I wrote down 1 and 30. And then I went, well, what about 2? Does 2 go into 30? And it does. It goes in there 15 times. 2 times 15 is 30. So I had to write those down. That's very easy to miss because it's not on your times tables. What about 3? Well, 3 times 10 works. So I wrote down 3 and 10. And then what about 4? No, I can't times anything by 4 to get 30, not a whole number at least. And so I skipped that one. And what about 5? And yep, 5 times 6 is 30. So that's how I got all the factors. And then I just looked and I saw, well, 5 is the highest one that is on both lists. And so I wrote down my answer. Now, the next one was asking about a prime number, and so it was for 7. So I racked my brains and checked my times tables to see if anything else multiplies to get to 7 except 7 and 1. And there was nothing. I couldn't find anything else. So I wrote down that only 1 times 7 gets me 7, and so that means it is a prime number. If I could find anything else, it would have been a composite number. With the next one, we are doing 2 to the power of 3. Remember, that means 2 times by itself 3 times because that little 3 up there. So I just wrote down 2 times 2 times 2 and then just worked out the answer underneath, which is 8. And then finally, with the last one, this was our root, our cube root. Because of that little 3 up there, I was looking for something that multiplied by itself 3 times to get to 125. And so I did my trial and error and I went 1 times 1 times 1. That didn't work. 2 times 2 times 2 didn't work. I kept going until I tried 5 times 5 times 5, and that worked. I got 125. That means the answer is just 5. Okay, here are some more practice questions for if you need to have a go at some of them. Remember to pause the video until you're ready to see the answers. And there they are. Hopefully you got them right this time. If not, remember to seek extra help from your teacher. And that's the end of this lesson.